Hey guys, welcome back to the Beginner's Guide to Restoring Classic late 1940s black and white televisions based around electrostatic type deflection picture tubes. In the last installment we talked about some of the circuit considerations to use that type of picture tube, in particular high voltage capacitors and special resistors. In this installment, we're going to try our best to get a glow of some sort on the face of a cathode ray tube. Now, I've already replaced those high voltage specialty resistors. We're going to continue on and replace the 5 high voltage capacitors with some nice shiny new ones. So that should take care of the divider string to generate the focus voltage and the horizontal and vertical centering offset controls, and the capacitors will take care of coupling signals to the deflection plates. What else do we need? Well, we need high voltage, and that is driven by a 6V6 tube feedback oscillator. So we may need to replace a paper cap or two, chuck some resistors to get that going, and then we need the main power supply that powers all the circuits in the set. That's really all we need to get at least a dot on the face of the CRT. We don't need the audio circuit to work, the video circuit to work, the tuner to work, the IF to work, or even the sweep circuits to work. But we do need to worry about that main power supply because that powers the circuit that drives the high voltage coil. And that consists of course, the main power transformer, a 5Y3 rectifier, a filter choke, and 2 filter electrolytic type capacitors. So we're going to be replacing those 2 type of caps as well as the high voltage caps. Let's get to it. Let's take care of those high voltage caps first. They go in here. So I mentioned in an earlier installment there are 2 basic options for you. One is to get white plastic film axial caps from Just Radios. The other is to get these red boxy Vima caps from DigiKey or Mauser. Well, I'm going to show you both because there's something I want to point out with these. So let's do these first. Now, sometimes I've had trouble getting the 4700s to replace the 5000 picofarad original caps, or the .005. So we're talking about these guys. So I've had to go with 6800s, which are just fine. So let's go with those because they really hammer home the point I'm trying to make about this. So we want to replace one of those with one of these. So got an obvious problem. Leads aren't long enough because the original leads went out to about that far. We have little dinky leads. The other issue is these are a little bit heavy. So we need to put extension leads on them. Now the bus wire I typically use is this stuff, 600 volt, PVC insulated. I believe it's 22 gauge wire. Now if I use that on these, it's a little flimsy to hold up the weight of this because it's going to be hanging in space, like say here, and it's supported entirely by the length of its leads, or by the leads. You could rest it so it's like that, but of course when this is in the set it's going to be turned the other way around, so it's really going to need to be supported. So I suggest you get some heavier gauge wires, some 20 gauge. Now the only 20 gauge I have is bare bus wire, but that's fine. I'll slide some heat shrink over it. So I'm going to cut off a couple lengths of this and we're going to make some extension leads, alright? But something we need to take into consideration when we do that. High voltage. Notice down in here there is goo smeared on the leads or on the lugs. And all around in here on these, there are some resistors mounted on this board all around in here. Well, why did they do that? Corona discharge. When you have high voltage and sharp points, the charge builds up on it and it kind of radiates. You get, like, if you were to turn all the lights off, you'd see sort of a purple, bluish cloud around it. We don't want that. Aside from producing ozone, which isn't so great for your health, it can reduce the high voltage and eventually can start arcing over to some other stuff. So that's why they just smeared this goo on here. The other way to prevent it is, well, to do a neat job with your soldering. By neat job, I don't mean wrapping a wire nicely and tinning it and soldering it. I mean making a big blob, which is what I did when I soldered these in place. So there are no sharp points on these. So I'll show you what I mean with one of these guys. So let me take some bus wire and wrap it around and show you the way you don't want to do it. So I might think, well, I'll just take this wire here and I'll bend it over and I'll put it around this and I'll crimp it. So I need those pliers and then grab some solder and solder that right. And there we go. Great, right? Nice, neat job. Worked fine. Yeah, except for one thing. We got this sharp point on the end here. What I suggest you do is take this and bend it over. You don't really go either way, but I usually bend inwards. And let's undo that. I'll clip it off. And let's make a hook again on this. The reason I bent it inward is so that when I do this, I can hook them together. I can crimp both of them. Make it mechanically sound. And then we're going to glob on some solder so we get a bit of a blob on there instead of having that sharp point stick up or on the sides. Normally you don't want to do this. You want to make a nice, neat job and use a minimal amount of solder and make a clean job of it. Well, it's pretty good, but I want to put on a little bit more. So I'll load up my soldering iron and go over it and touch it to it and do something like that. So that should work out pretty well. Don't have any sharp points sticking up. It's cooled off. So. And yeah, I don't feel any sharp points at all. Now, if it still was a concern, yes, you can take Corona dope, also known as liquid electrical tape. It's this black stuff, smells horrible, very messy. But if you do end up having any Corona or arcing in the set, you can paint this on. Aside from it being smelly and the solvents and it's smelling pretty bad, if you ever have to rework a joint that has that on it, like if I need to do any work over here, it smells horrible when you melt it. And it's not really easy to get off or chip off. I suppose you could try using acetone or something like that to melt it off before you work on it. It's just really unpleasant to have to deal with. If you do a blobby solder joint like that, you shouldn't have any trouble. Now, the other thing to consider is there's only high voltage on one side of the cap, and that's going to be on this side. So that's where you want to focus your effort about making a good blobby solder joint. The other side will only have a few hundred volts. This side will have 5,000 or so volts. And as far as insulating it, I got a big old roll of heat shrink tubing. I can just slide some of this over it. Now, I don't expect the heat shrink tubing to stand up to 6,000 volts. So you also want to keep this away from anything. And basically everything in this area is at a high voltage potential. So you don't really have to worry about this arcing into, say, these wires, because these wires have high voltage on them as well. And notice all these pots, which also have high voltage on them, are mounted on a phenolic board and have plastic shafts, because all this stuff is high voltage. It's all at similar potential, so things don't arc to each other very much. But what would they arc to? The chassis, or the tube socket over here, or free air if you have a sharp point that's, well, not covered in goo. Now I need to figure out take my cap, figure out where it's going to go. So you want to use the larger value caps for the vertical deflection. I need to refer to my schematics. It's been a few days since I last worked on this. So that's going to be the plates of the 6SL7. So we've got one going to pin 2 and one going to pin 5 on the 6SL7, which is this guy right here. Now this may look odd to you. On that tube socket there's rather odd construction technique. There are two 4.7 meg resistors coming up, connected in midair with a wire going off. That's factory. That's the final end of that high voltage bleeder chain. Those are going to the plates of the 6SL7. And again, because of the high voltage, they put a terminal strip here, go into the chassis and mount and have those two resistors going to it. It would arc through it. Or potentially arc through it, because you've got a few hundred volts up here. Like 400 volts, something like that. And, well, that's how they chose to do it. I also suggest you replace these two resistors. We won't right now, but you should in the long run, because they're a critical part of the operation. It's not so bad if they both drifted equally, but if they are not equal to each other, it will offset your image. And you might not be able to have enough range on your vertical centering control to get it into the middle. Alright, so we want to attach one of these there, and then we also got to figure out where it goes to here. You should probably clip these out one at a time and pay more attention, but I've done this before, so I'll figure it out. Plus I took lots of reference photos. And I can see, I click and see what it leads are clipped out over here. So one of them goes down here. And that's, yeah, it's a vertical centering control right there. So vertical output, vertical centering, of course the caps just go between here. So I need to attach an extension lead on the other end and remove that earlier attempt I made. So yeah, so imagine you can tell here, the axial are easier to work with, these guys, but they also cost 6, 7, 8 times as much. And you're going to have to, depending on where you live, wait for them to clear customs and all that kind of stuff. Because they're coming from Canada. I took a fresh look the other day because I was curious, like, maybe somebody else has them now. I went to ASC's website, who makes them, or SHV also makes them. Looked at distributors and all that, and nobody else seems to carry them, so Just Radios is your source. A bit of bus wire. And this one goes down here. That's the other side of those 4.7 megs that are sticking up in the air. And heat shrink tubing somewhere. One needs to go down there. So there are some resistors on this board that I haven't replaced. They're 4.7 megs. It's 1, 2, 3, 4 of them. Yeah, may very well need to get in there and replace those. And it's a lot easier if you take this board out. It's held in by 2 screws coming from the top. Just a fair warning. You may need to get in there and do some work. It's a little tricky. And be very careful with these pots. Those plastic shafts can expand over time and be hard to turn. Just carefully work them back and forth because they're hard to replace. I don't know if you can get pots that are made these days with plastic shafts that can withstand that much voltage. That's good enough for this. Move this up a little bit. Alright, so I'm going to keep going. I got 4 more to do and we'll pick up. Alright, that's done. 2 red for the vertical. This white guy is the filter cap right after the high voltage rectifier tube, and then these 2 skinny white guys are the horizontal coupling caps. Now I mentioned about power supply filter caps. Well, those are down here. So there's one mounted on the side. That's a replacement. And upon inspection, I'm pretty sure that's a replacement too, because the original should be 2 sections, each of 30 microfarad. And this cap has 3 sections, 2 30s and a 20, and they connected a 30 and a 20 together. I think that's a replacement cap. So I'll tell you what we're going to do. We're going to try powering this up without replacing those. Thought being that if they have enough life left that we can start getting some functionality in the set, all the easier, because then we can start replacing one component at a time and hopefully see progressive improvement in things. So that leads us to, well, I said I wanted to see glow on the picture tube, right? Well, we don't have one. I took the one that was in this set out and put it away for safekeeping. We're going to plug something into it. Well, turns out there are some scope green phosphor oscilloscope type CRTs that have the same base pin out. So that's what I'm going to use. This looks just like a 7JP4, right? Except the screen looks a little different if you've seen P4 phosphor before. This is actually a 7VP1, which has the same 14-pin base as a 7JP4. Just green phosphor instead of white phosphor. So we're going to plug this in. There are some others, like a 3BP1, which is a little 3-inch scope CRT. And so one I showed earlier. I'm not going to completely reveal what this is yet, but the 3BP1 looks something like this. Now, if you look up the specs on, say, a 3BP1, you will see that the maximum allowed high voltage is something like 2500 or 3000 volts. So you will be exceeding its ratings. However, I've heard from other folks that have used it that it seems to work all right. So there you go. These are not easy to come by. Actually, these probably have a harder time finding one of these, unfortunately, than a 7JP4, because they were only used in scopes by a few makers. I got this out of a Sylvania oscilloscope. But there's also very little demand for them other than basically people who wanted to use them on the bench like I'm using this one on. They are out there. Your best bet is to just buy a scope that has the type of CRT that's compatible with this and scavenge it out of it. I don't think I've ever seen just a bare 7VP1 or 7JP1 for sale anywhere. But there are plenty of old. I don't think it's any tragedy because the scopes that use these are really inexpensive scopes. So I don't think I'm going to be really committing sacrilege, I don't think. So I'm going to put this in. Alright, I'm going to need to elevate. How am I going to do this? I'm going to put this on its side. So I want to be able to access the bottom, but also see the CRT. And it's a little awkward with it upside down. So I'm going to put it this way. If I put it on the other way, then the scope will be unsupported floating in air. So we'll do it like this. The CRT will be unsupported, I mean. That's it. It's okay. We don't need to clamp it really or anything. It's okay. The reason why I have this done is a scrap of carpet. It provides some padding so I'm not smacking glass against a hard workbench surface. I'm going to put a little something between this and the high voltage box that the neck is resting on right now. Like so. And yeah, I think we're good. I'll plug it into my PR57 because it has built-in current limiting, and I can see how much the current draw is. And oh yeah, the tubes. So most of the tube sockets are unpopulated right now. I don't need to put in all the IF tubes and stuff, but I do need to make sure I have the. See, I got to install the 6V6 for the high voltage oscillator and put the rectifier tube in. And I think I'm missing a sweep tube or two, so let me pop those tubes in, then we're going to fire this up. Alrighty, I'm going to turn this on. It's a 1.5 amp current range. I expect it's going to swing up and it should come down. Should start going back up. Hey, look at that. we have glowage. Damn, we have a raster. Well, hot damn. That's better than I was expecting. Fantastic. Which means, whoa. That's what happens when you tack caps in place, is you occasionally get a spark. But hey, look at that. So you have horizontal and vertical deflection and high voltage. What sparked, I didn't exactly see it, but I assume some charge built up on something back in there, and with that one crack it cleared itself out. Well, that's cool. And that's why I replace those high voltage components first, because more often than not, this is the kind of results I see. Although I usually don't get a full raster quite that nice. You got to do a bit more work on the sweep circuits to get full deflection. Let's see, it's a bit out of focus. So let's see if we can adjust the focus control. Yes, we can. Or at least I did. Seem to be working anymore. That's odd. There's one of our Soldering controls, and yeah, it's not. Let's see. This one. Huh, doesn't seem to be doing anything. Oh, a little bit left, right. So these Soldering controls are not working right. So I suspect I will have to go up to those 4.7 meg resistors that I was avoiding messing with, because this is exactly what happens when those go bad. So I can move this down a little bit this way, but I can't get it to go the other way. And the other Soldering control, well, it's not really doing that. I should be able to move this up and down and left and right pretty significantly, like at least a good inch in either direction, and I cannot. Well, my goal was to get something on the face of the CRT by the end of the video, and boy, did we. So I'm going to wrap things up here. Next time, we're going to work on the centering controls. I'm going to try replacing those 4.7 meg resistors. So I should be able to move this rectangular around with ease, and I cannot. And then go after the vertical, because the height control isn't doing anything. Once we've got a good, stable raster that we can move around, get it centered, get the height and width right, then we're going to go after the video and sound circuits. That's it for now. Thanks for watching.